Hi there, let's have a look at question 3. This is an inequalities question, and it tells us to use algebra to obtain the set of values of x for which this particular inequality holds. Now, just before we dive into it, let's just have a quick recap. You've got to be quite careful with modulus inequalities. So if I've got a modulus is less than, let's say, g of x, let's just figure out what this means graphically. I want to figure out what it means with some numbers. So if I draw, let's say, a function like this, which I'm going to call f, then the modulus of f is going to have the same values when it's positive and then reflected when it's negative, something like that. So that'll be the modulus of f. And then let's say we're comparing that to some function which I'm going to call g. Then we can think about this in some different cases. So we've got two kind of cases to consider, which is if f of x is positive, then the modulus doesn't affect anything. We are just simply looking at the region where f of x is smaller than g of x. So that's our first case to consider. Our second case, which is a little bit more awkward, so if f of x is negative, so like here or something, then when we do minus the value, when we reflect it, we want that to still be less than g of x. So minus f of x, we want that to be less than g of x. Or you could also think of this also much easier as f of x greater than g of x. Greater meaning less negative, so when you take the modulus, it'll make it less positive. So we need to split up into these two cases. So I'm going to do the first case first. So if f of x is positive, f of x less than g of x. So what I'm looking at is x squared plus 3x plus 10 divided by x plus 2. Where is that less than 7 minus x? Now, before I go any further, we just need to make clear where this is the case. This is when f of x is positive. So we need to be clear about when f of x is positive. So f of x is our function in the modulus. Now we can look at when the denominator is positive or negative, but then we need to look at the top term as well. Now this is a quadratic. It doesn't look like it factorizes nicely, and complete square is a little bit awkward. Let me do the discriminant for it. So b squared minus 4ac would be 3 squared, take 4 lots of 1 times 10, which is minus 31, which is negative, so it has no real roots. And then if I put x equals 0 in, I'm going to get y is 10. So this top term is always positive. So in other words, we're only interested in when the denominator is positive or negative. So for f of x to be positive, that must mean the denominator is positive. So that must mean that x plus 2 is greater than 0. Or in other words, x has to be greater than minus 2. And we can then do this work for. It's going to be similar for the second situation where we're looking if f of x is negative. So that's if x plus 2 is negative, or in other words, if x is less than minus 2, then we can do the result. So if I just come back to my first case solving that, so I'm going an easy way, rather than fiddling about whether something's positive or negative and multiplying through, which you can do in this case because you know x plus 2 is positive, so I can times by the denominator and it won't affect anything. So let's take advantage of that, let's use that. But something that might be, say, better, I think, to do is always just to subtract things. So if I minus the 7 minus x, that would be less than 0. And then I can combine the like terms. I can get a common denominator and then combine them. But in this case, I could also multiply by x plus 2 because it is positive and it won't change the inequality sign. I would in general avoid doing that though, just if you can, just to make it a bit easier. So combine my common denominators, x squared plus 3x plus 10, so that's going to be minus 7 minus x times x plus 2 all over x plus 2, and that's negative. And then we just need to, we can pretty much ignore the bottom term at this point because we know that this thing is positive, because that's in our assumption from f of x being positive. So I can just simply look at the top term, minus 7 minus x, x plus 2 being negative, because that's what we're trying to solve. This is almost likely times my x plus 2 here, which I can't do again because it's positive. So then let's expand brackets. So I'm going to have 14, I'd have plus 7x minus 2x, that's plus 5x, and I've got a minus x squared. And then x squared minus x squared, that is 2x squared. 3x minus 5x is minus 2x. 10 take away 14 is minus 4. I can divide through by 2 because that's positive. And then I think I can factorise that. X minus 2, x plus 1 being negative. So then we've just got to look at our graph. So roots are at positive 2 and negative 1. So something like that. So positive 2, negative 1. Where is it negative? It's negative in that region there. So we've got minus 1 less than x less than 2. Okay, so that's our first sort of solution. We now need to look at the second case. So we said that if x plus 2 were negative, I'm going to get x is less than minus 2. And when we're coming to looking at this, we've got minus f of x is less than g of x. So minus the whole thing over x plus 2, and that is less than 7 minus x. Now again, where possible, rather than multiplying, it is better to add or subtract things. So I'm going to add this fraction to both sides. So I'm going to get 0 is less than 7 minus x plus x squared plus 3x plus 10, all divided by x plus 2. I'm going to get a common denominator, so 7 minus x, x plus 2 divided by, divided by x plus 2. And I need my plus x squared plus 3x plus 10. And then I'm going to get 0. I need to expand this, so I'm going to get, again, 14. I'm going to get plus 7x minus 2x, that's plus 5x. That's the same as what we expanded for. I don't know, I'm wasting time with this. Minus x squared, same as that bit that was there. And then plus x squared plus 3x plus 10, all over x plus 2. So we're looking at where this thing on the right is positive, and we know that the denominator is negative. So we're trying to solve for the numerator being negative. So let me cancel some terms, and then I'm going to write it as being less than 0. So we've got 14 and 24, so 10 and 14 make 24, plus 5 plus 3 is going to make 8x, and the x squareds are going to cancel. So we're looking at where this is negative. Because like I say, we know the denominator is negative because that is our assumption here. So we're looking just when the numerator is going to be negative. So that's going to give me 8x is less than 24, minus 24, which is going to give me x is less than minus 3. So our solution, if we want to write it in interval notation, so that is minus infinity up to minus 3, close bracket, union the set minus 1 to 2, like that. Okay, you don't have to write it like that, you can just write it as these two, but please make sure you use the word or when talking about them, because we can't have a number being less than minus 3 and greater than minus 1.